But hello everyone. This is Sahej. I work as an application engineer with the 96Boards team at Lenovo. And past year or two have been very exciting for open source GPU drivers, especially in the ARM space. And they have really opened up like a door to a lot of possibilities with dev boards and like a lot of wow, not sure what happened there, but a lot of old dev boards have sort of come back to life because now their GPUs can be utilized as well in a useful manner. So last Linaro Tech Days, I kind of missed the spirit of Demo Friday. So today's session is more of a demo of different boards running these open source drivers rather than an in-depth detailed talk about what the drivers actually do. There are people who are far more knowledgeable than me in this regard, and they have talks on XORG Developer Conference from this year, earlier in the year, and that is a really good source if you want to get into the nitty gritty working of Mesa and the Linux display stack in general. I'll go through a bit of that stuff, but um, not a whole lot. I'll be focusing more on the demos because I have some cool tricks to show you guys. So, getting started with that, this is the Linux display and graphics subsystem. Um, Kind of complicated, but it's all pretty easy to grasp when you take a look at this flowchart for a while. So the main thing we're going to focus is on Mesa today, and there are some kernel bits that are there and are required, but mostly the magic happens within Mesa. There's the DRM driver, which is the kernel part that communicates with the user space Mesa driver, and then the kernel itself. The one thing wrong here with this flowchart, I won't actually say wrong, but could have been added, is that usually there are two DRM drivers working together, because take an example for the RK3399 where the actual display subsystem is provided by Rockchip. So you have the Rockchip DRM driver for the display subsystem, and the GPU is provided by ARM Mali IP, and that's provided by the Panfrost driver in our open source situation here. And similarly, with a lot more, like Allwinner has their own display DRM, and then some of them like IMX, AM Logic, STM all use the DW designed by display subsystem IP, but they still have their own like driver. So you'll have Mason DW driver, STM has its own DRN driver, and so on and so forth. So apart from that, yes, Mesa is sort of the thing that magically translates EGL and OpenGL and Vulkan and OpenCL calls on to and run that on your GPUs. This is the sort of messy clockwork magic of Mesa. Now, this is not the entire Mesa project concise in a few in a small flowchart. No, this is just the compiler stack, and basically NIR is where all the magic happens. It's been standardized a lot more. NIR is this magical layer which converts your all the shader stuff uh, into the sort of the intermediate level, and then it spits out whatever driver you're using. So in term of Panfrost driver relies on an IR, and then um, so does Adreno, so does Zink. TGSI is sort of the depreciated version. There are some old drivers, some really old NVIDIA stuff. Etneviv still uses TGSI, um, and then the LLVM pipe, which is the software renderer, uses TGSI. LLVM pipe is another really great stuff that I like because it uses the Clang backend. Uh, it has the ability to be highly parallelized. So if you ever run anything on LVM pipe versus VertIO, you can see like while running it while running Edge top, you can see the CPU utilization differ quite a lot with LLVM pipe, utilizing as much cores as possible. The other thing that LLVM pipe, or I should say LLVM IR, provides is OpenCL support using again the Clang backend. So that is used by Mesa's Project Clover, and all the LLVM pipe um, and the Radeon drivers, so RADV and Radeon SI, both use the LLVM IR as the backend. And so the Radeon graphic cards, and if you're using LLVM pipe, you can actually run OpenCL on Mesa. As far as I know, there's some work going on to get uh, OpenCL over Spur V running, and at that point you will not need LVMIR to get the OpenCL stuff running. Um, but yeah, so that's sort of the overview. Again, more details is like on Xorg DevConf, and I'd recommend everyone go there. So off to the good parts, which are the actual demos. Um, First one is at Naviv. Now 96 boards has a few boards. We have the IMX8 based AI/ML boards, and we have the Thor 96, again IMX8 based, but both of them have, I think, not don't have the HDMI stuff upstreamed yet. Also, STM32MP1 is a much recent SOC, and after a long time, I've seen someone other than IMX utilize the Vivante GPU drivers. So this one uses the Vivante GC400, which is like their super low cost um, solution, which is like they have um, like less than 1 millimeter square silicon area and stuff like that. So it supports very basic OpenGL ES calls, and extremely cheap to implement, and it's a low power solution. So let's actually switch. I'll need to stop share and switch over to my webcam. I'm not sure if I'm being pinned, but I think is my webcam being pinned or not? I can't see. Um,
I can still see your black screen with the code on it.
right. So I guess everyone can see that then. Which is right. So I don't have an Xorg base or like a GUI based demo here. I just didn't have time. This is a basic build root build, but you can see it's a um, dual core Cortex A7 solution. This is the STM32MP1, as I mentioned, with the GC400. Running the latest mainline stuff, 5.8.7. I just built it recently, and I can run KMS Cube on it. Runs on the open source driver just fine. And again, if I back out in a second, it clearly shows OpenGLES2.x on Etneviv and Vivante GC400. But if you see at the frame rates, they're not very exciting. But like that's what the performance of this GPU. It's basically made for basic. Um, I'm guessing Qt based GL stuff that runs on embedded processor. So like even the basic KMS cube only runs at 60 FPS. And I'm pretty sure that's not a refresh rate limitation here, because I've had it also show 70 FPS on certain other when it's like properly cooled and stuff. So it's not uh, a limitation of the monitor refresh rate. But yeah, that's for the Etneviv stuff. That's the only one I have at hand right now. So we'll move on to our next demo. This was a short one. Next up, we have Panfrost. Before I go further, I mean, congratulations, Panfrost people. Like basically, ARM giving you all the support they have, and This is actually amazing news that ARM is now backing the project. In any way, they like. I hope that this support leads to ARM actually releasing Panfrost-based drivers for their upcoming GPUs out of the box rather than the binary blobs they have. It's a pipe dream, but anything's possible at this point. But just ARM coming out and openly supporting the project is amazing news. So yeah, that like really shows the power of open source. But yeah, Panfrost provides the open source driver, again reverse engineered initially. I'm not sure how they'll go forward now that ARM is being involved, and provides support for Midgard and Bifrost GPUs. Today I'll be showing it on the Rock 960, uh, running the RK3399 with the Mali T860 MP4 GPU, so kind of a mid-range deal with OpenGL ES 1.12 and 3, and we'll be demonstrating the GL3 as well. I so again with Panfrost, they have done work on Bifrost or the G series GPUs as well. Again, we have a couple more boards, and this is where the interesting DRM bit comes in. Like we have Heike 960 and Heike 970 both running Bifrost GPUs, which would have been a great candidate. But now, remember the second DRM bit that I talked about, which is the display engine on the SOC. So that's not upstreamed for those boards. So that means even if we have the Bifrost GPU running, it runs in an off-screen mode because like the SOC can't display anything because that DRM bit is not enabled in our upstream kernel as long as I recall. The High-key has DRM enabled for High Silicon has DRM enabled for high 6620, which is in the original high key, uh, but the IP changed when they shifted to the new platform. So 960 and 970 have the same display engine DRM IP from High Silicon, and that's not upstreamed. So I have the Rock 960, and let's get to the demo of running cool stuff with it. The other thing is that this board is kind of touchy when it comes to switching HDMI. So I will have to plug and replug and then power on the board. This board is running uh, Fedora 33, and since the U-boot is pretty much well upstreamed, I'll stop screen sharing so you can see U-boot boot. Yeah, like the U-boot graphics work as well, so display output works as well and everything. So this is mostly EBBR compliant from what I recall, and I have been on and off working with Peter Robinson to test this board and make sure that it's well supported in Fedora. So hopefully, yeah. So it's running up all everything upstream, like U-boots upstream, and then proper distro. So just waiting for it to boot takes a few seconds, and I was afraid this was going to happen. I'm not sure why the HDMI is so finicky on this board, but yeah, GNOME should show up any second now. There's pointer, and there we have it. Login. Right. So as you can see, wait for it. I spoke too soon. Yes, running stuff from SD card is not the fastest way to do things. Uh, when your bootloader's on the eMMC, what other choice you have? So there you go. Boots into GNOME just fine, and GNOME is working fine as well. But that's not the stuff we are looking for. What we really want is some GL Mark II runs. Now, of course, I won't be going through the entire like GL Mark II suite. It's just going to take a lot of time. But just to prove a point here, it's running Panfrost on the Mali GPU. Again, GL Mark II is just 2.1, so you won't see any 3.0 stuff on this demo. But if I run Super TuxCart, um, oops, that actually runs OpenGL 3, actually requires OpenGL 3, not only runs OpenGL 3. And that is an actual demonstration of the GPU running in OpenGL 3 mode. So here we go. And I can go into a quick race. Wait for a few seconds again. We are running on an SD card. While this loads, yeah, EB bar should have like SPI flash mandatory. Uh, this is, whoops, that's not supposed to happen. All right, I'm not sure why it crashed. It usually runs fine. Um, but what's a talk without stuff crashing? But I've run this, so I can actually run another demo that might work better. This one's called Mind Test. It's a Minecraft clone, but it's like a really good clone. Um, it basically supports up to open, like I've run it on OpenGL 2 as well. Be happy with whatever it gets. So yeah, it's a voxel based game, so it stresses the CPU a bit. But what we are looking for, that there are no rendering artifacts, and it's working just fine. The smoothness really depends on what environment you are in within the game, and it can vary from like place to place. If it has to render less blocks, then like FPS will increase quite a bit. But if you're in a space where there's large open things to render, then it will have issues. But anyway, I think this is good enough demo on my end for Panfrost. Performs well enough. Um, and I've never run this GPU using the closed source driver, so I'm not really sure how close it is to like the actual GPU's performance. But I'm liking what I'm seeing. So like, yeah, I'm getting close to 30 if the conditions is right, which is good enough for a low to mid range GPU. So good on Panfrost folks, and I'll be keeping my eye on the Bifrost development that happens, uh, because it's going to be nice to see or actually have another demo, hopefully in person, um, when possible next year. Right, back to the slides. So the next bit is Adreno. This is available on a bunch of our boards, starting from Dragonboard 410C, which is the Snapdragon 410C based board, and then the one that I'll be demoing today is the RB3. There's also the DB 820 in between, or Dragon Board 820. The RB3 is based on the Snapdragon 845, which is last year's or last generation's top end smartphone SoC. And then we now have the RB5, which I don't have in person due to shipping issues. Right now, the world's not entirely sane, so shipping is weird as well. Um, yeah, so RB3, I'll be demonstrating. It's a really, really nice sock. It's a really high end sock. So yeah, demo is going to be cool. Uh, Again, yeah, so FreeRhino provides the MSM DRM drivers, the actual FreeRhino or the Adreno drivers, and the XF86 stuff to run Xorg on. But again, we'll be using the Qualcomm landing team's Debian distro to run it, which runs very very close to mainline, um, with some to be merged patches already applied. So we are running very close mainline stuff on this, and this does up to OpenGL ES 3.2. I'm not entirely sure what the free Adreno drivers goes up to. I think it's pretty close. So again, I'll switch back, and I will quickly switch out to the RB3. Oops. Oh, Um, and there we go. So as you can see, the Snapdragon 845, and we are running kernel 5.7, very very close. Now this has Mesa master build for a very specific reason, which we'll see in our next demo. But just for a quick look, um, I'll run Super TuxCard on this. Uh, and this is running on. Oh, did I not install Super TuxCard? Oops, my bad. We'll run mine test. Um, and since this is running actually pretty decent GPU, one of the more higher end ones, um, it gets much more FPS. So you can see we have around 45 to 50 FPS, and looks really smooth. Now I do want you all to sort of notice the sort of a glitch. Now I have opened up an issue with the Freedrino folks, and this is being looked into. But I need you to look into this transparency issue a bit closer for some other reason, which my next demo will clear out. Um, so we'll just exit from here. Uh, I'll give you guys a quick run of GL Mark II so that let's see. You guys can see what the actual performance is. So we are getting around 1700 FPS on the first test, uh, which should be a ref indication to what this GPU is actually capable of. Now to the much more cooler part, um, something called Turnip and something called Zink. Now, Turnip was a project that just got like announced last year. So I was at the Bangkok Linara Connect, and I've heard about it that there. And the it's an open source Vulkan driver for our Adreno hardware, so for the Qualcomm GPUs. And when it was announced, the first thing the description was it renders a very specific Vulkan triangle. So it was in no way compliant. It didn't run general demos. But now, like just 1 year after it's been merged into Mesa, also like just directly a part of Adreno driver now, much better code base, and runs a lot of examples really well. Like they say that it's not a fully compliant one, but like I've put in it through its paces. Of course, not done the compliance test, but in terms of demos that are available for Linux and that can be compiled for ARMS, it's run them just fine. And then Zink is an OpenGL implementation on top of Vulkan, so we'll look at that as well really quick. Um, and I will stop the screen share. And so on here, I can run VKmark, and that runs just fine. So I can just go through all of the demos in VKmark and it runs fine. Again, it shows the warning that it's not conformant to Vulkan implementation, but it's still running fine. So it was getting around 6,771 FPS on the first demo, which is kind of comparable to what the OpenGL stuff does. Um, the other demos we have is from Shasha Williams' library of Vulkan demos, which have been there for a while and sort of one of the best sources of testing out Vulkan in a fun way. But I'll just run uh, one of the demos because again, it's going to take a lot of time if I run every one of them. Um, but again, I have tested every one of them and it runs fine. So this is compute cloth. Just looks kind of looks cool when it's running, and it's it's computing the like the actual fabric um, simulation, how it should fold and everything around a sphere, and yeah, that just runs fine. 141 FPS, which is comparable to a lot of benchmarks I've seen with this demo, and um, yeah, VK is running fine. But like the crazy part is like it's the turnip is good enough to run Zink, and Zink is again, as I said, an OpenGL implementation over over Vulkan, and that is hardware agnostic. So if you have Vulkan driver enabled, you can basically get OpenGL as well, which sort of shortens the time for a driver development. You just have to do the Vulkan stuff and you get the OpenGL stuff through Zink, and it works fine. Of course, there is a performance penalty now, but there's no reason it couldn't improve in the future. It's a very very young project, and for the most part, it's running fine. Now, if you remember the mind test glitches that I showed you, now because this is a fresh implementation of OpenGL, again over Vulkan, those glitches aren't apparent anymore because they go away. It's like, so see, all the transparency is back. Of course, we have taken a massive hit in terms of FPS, but again, this is like the same demo as before, but again running on Zink. So if you only spend time developing the Vulkan driver really well, Zink helps you get to OpenGL very, very quickly. You just enable that. So again, this is even more beta or alpha level stuff than Turnip because you have to like specifically enable it by overriding the default Mesa loader, and yeah. So this was sort of the array of demos I had for the short time. I'm not sure if I've overrun the time, but I think,
Just a couple minutes.
yeah, all right. I think I can take questions, and also I'd like to thank all the developers of these various projects who have helped me along the way, and I've been asking them questions on IRC for the last year or so, um, and especially Daniel Stones because we've just had a chat on over email about how all the internal Mesa NIR stuff works. So thank you for that. Um, yeah, I hope like these developments go forward, because open source GPU drivers just makes life easier to bring ARM to desktop, and any questions there may be.